Today I talk about the production of X-ray here and its characteristics. Here we see the X-ray production tube, that is Coolidge tube. Here electron comes from the cathode and with a high velocity hit to the target material, and its energy reduced and we can get X-ray. X-ray is an electromagnetic radiation of high energy, that is low wavelength. There is two types of X-ray characteristics curve, or two types of radiations come from the target material as X-ray. One is beam Stirling or continuous radiation, and other is characteristics radiation. In beam Stirling radiation, the electron comes from the cathode, hit to the target material, its energy reduced, and the reduced energy we get the reduced energy as a form of X-ray. As we know that energy is conserved, and the X-ray X-ray is continuous. The continuous spectrum we get from in the X-ray tube by the interaction of electron to the target material. Since the energy must be conserved, the energy loss from the interaction results in the release of X-ray photons. Here is the continuous X-ray figure, and this is the characteristic curve of continuous spectrum. Here we plot intensity versus wavelength, and we see that here no bump or no certain peak shown in this picture. The X-ray characteristic X-ray produced when the electron comes from the target material is high, it hits to the electron of the atom on the target material, and electron knockout from the first cell, that is K cell, and the vacancy is obtained. To so to from the higher energy state, the electron comes to the vacant cell, and the energy reduced by the electron, and we get K alpha, K beta, etc. line. Here is the characteristic curve. We say alpha and beta certain peak, which is characteristic curve. And if the electron comes from the L cell to K cell, we get K alpha line, and from L cell to K cell we get K beta line, and so on. This is how K alpha, K beta line produced. The electron from the K cell is knockout. The electron comes from the higher cell to fill the vacancy of the K cell, and we get K alpha and K beta line. How we get, we say earlier. This is the tungsten 74 atom. If electron comes from L to K cell, we can get the X-ray of energy 58 kilo electron volt. M to K cell we get 67 kilo electron volt, and M to L cell we get 9 kilo electron volt energy. This is a figure how to electron knockout and how electron comes from the higher cell to fill up the vacancy. These are characteristics curve if the target material is used, aluminum is used as target material, and this is the copper material as a target material, and from this peak we calculate the atomic number, that is atomic number Z of the material. Thank you.